Hey folks, welcome to Advent of Code in F Sharp, day 3. This morning I had a stab at the problem with limited success, so this will be my second attempt. I'm gonna try to keep it simpler as my previous one, because I was down a rabbit hole that I did not end up coming out of. So let's try this again. I'm not gonna read the full exercise, I'll leave that up to you. But essentially we are being tasked at finding numbers that are adjacent to a symbol, and then we have to sum those numbers that are adjacent to a symbol, which are the part numbers. And my approach that I'm going to try is to actually do the hard work while we're parsing. So we're going to parse into a structure that represents these numbers and their locations. So the number 467 and where it's at, and also the symbols and their locations. And then we can just, for every number, look around it. Is there a symbol around it? Okay, then we take that number. So that's the idea. And the hardest part about all this is parsing this schematic into this data structure. So let's give that a try. I grabbed the example here. Let's pull that into memory. I think it would be nice if we just start iterating over every cell in the schematic and get its coordinates, and then maybe do a little bit of parsing to digits and to symbols and to empty spaces, and we'll take it from there. So let's start with that. I'm going to use something new. It's called a list comprehension, which is basically a fancy way of generating lists. And you can use some syntax like this. So for every line in the example, I want to do something. And for every character in that line, I want to do something else. I forgot the keyword here. So I want to do something else. And let's just echo back the character, make sure that this works. And we need to close all brackets, of course. So now we just did nothing. We just iterated over the over the input. But we can enrich this. So say, for example, I want the coordinates of everything. I can make an indexed list. So there's an indexed function that takes a list and it returns a list, but every element in the list now also has its index. So that's useful. And then we can say the row number and the line. That's what we'll be iterating over. And in the line, let's just do just the same thing. So for every character, let's index that. And then we have the column number and the character itself. And now we have the indices. String does not match the list. Oh yeah, a string here. Line is a string. It's not a list, but it's a numeral or a sequence, so this should work instead. That's working, and now let's just also output the coordinates. So x is horizontal, that is the column number. Y is vertical, that's the row number. And the row grows downwards, sure. So now we have a list of lists, and every list is like a line with the index of whatever we're seeing here. So we're getting close. Maybe one step more I want to do in this initial parsing round is parse out the digits and the empty spaces and the symbols. So let's do that. Let's write a little parse help function. And I'm gonna do a pattern match with this function syntax. It's a shorthand for just a pattern match. You can do match x with and provide an argument x. It's syntactic sugar. But if we hit a character that's a digit, where's my character namespace? There it is. If we hit a digit, then we have a digit. And let's introduce a type here. So an entry is either a digit containing the number, or the digit also be a symbol, which is just something else than a number, or it's an empty space. So that's a basic data structure to parse our initial input. And if we have a digit, we need to convert it to a digit. I think this is not correct. If we take the int value of a character, we don't get what we want. So let's make it a string and parse a string into an integer. That does work, I think. So this is the digit case. If it's dot, then we have nothing. It's an empty space. And in all other cases, it's just a symbol. So this should parse. This should parse. Let's give it a try. It's parsing already. Cool. So we have digit 4, digit 6, digit 7, some empties, and then digit 1. That sounds correct. Let's maybe see if we can parse symbols. Symbol star at 3, 1. 0, 1, 0, 1, 2, 3. That looks correct. So that's our initial parsing down. So we don't have to work with raw characters anymore. We know what we have at every location. This was only a small part of the problem. Let's take the next step. And I think for me, the next step, because all numbers are horizontal. Yeah, all numbers are horizontal. I'm going to bundle adjacent digits into their numbers. So for example, we're going to take this 4 here, this 6 here, and this 7 here, smoosh them together into a single number, and the single number will occupy these 3 spaces. Yeah, I think for part 1, that will get us where we have to go. So this is the raw parse, which just maps our grid to something a little more friendly. And let's now, for every line, bundle the numbers back together, or bundle digits that are next to each other into numbers. So for every line, because we can do it horizontally, let's make a function. Let's make a function called bundle that bundles adjacent digits together. Yeah, and maybe I'm not gonna write new types. I'm gonna expand this type a bit. So we have an entry, which is a number, and the number is an integer, and it starts off with digits, but we don't need to know that. So this should all still work, but now we just renamed something basically. But now I don't feel so guilty for adding multiple digits in a number. Actually, that's not enough. We also need multiple coordinates. Yeah, revert. I am going to introduce a new type, I think. But let's first try to figure out this bundling. Let's first see how that would look like. So let's take a line. What's one line here? This is one line. So that's a line. Why is number not being a... Oh, it's digit. Great. Let me do that again. REPL is cool until it isn't. Come on, give me digits instead of numbers, please. There we go. Let's grab our first row. There we go. And let's start playing around with it. So that's the first line. We just parsed it. There we go. Let's now start bundling it. We could maybe work with a take while. Take as long as you encounter digits, and that's one single number. Yeah, that's maybe the easiest part. So, should we take a look at the first thing to make sure it's a digit, or can we just do take while and then try something else? I think that would work. So let's try take as many characters from this line while we have a digit. So every entry in the line is a location and an entry, and take while match entry with digit. Then we take it, and otherwise we don't take it. So this should give us the digits of the first number. 4, 6, 7. Yeah. So this approach could work, and then we need to interleave it with everything in between. That approach could work. I'm internally debating whether or not I should do a special case for empties and symbols, or we can just try to bundle everything, like a sequence of numbers. Digits becomes a number, a sequence of empties just becomes a long empty. Symbols are all differently, so that would be a bit of a tricky part. But that's maybe easier than what I would otherwise do. So just take whatever you can from the line that matches the type of the first thing, smoosh it together, and for symbols it's always something different. Yeah, let's try that. I'm gonna use a recursive function for that. And let's pattern match on the line. If it's empty, then we're done. Otherwise, we have a location and let's say number. We don't care about the location and the number. It's a digit, not a number. Yeah, this would work. So we take digit because our first element is a digit. We just take digits until we run out of digits, and then we return whatever. A bundle. Bundled is just a list now of entries and locations. Yeah, I'm just gonna return bundled, doesn't really matter, we can work with that, and do a recursive call bundle of everything else, and everything else is the line, but we skip a couple of entries, and that's exactly the length of this bundled, for example. So that's the rest, and we start bundling all the rest. And I think this would also work for empties. So we bundle empties, and we just grab empties while we're encountering subsequent empties, but that's not really needed. Yeah, you know what? Let's not do that. Let's just forward an empty and a symbol. So otherwise, in all other cases, we just grab whatever we have and we bundle the rest, the tail. Why doesn't it not like this? It does not notate. Oh yeah, because I also need to destructure. Yeah, and now we just need to line up these types of the return type and we're done. I am going to introduce a new type to make it really explicit. Type bundles is either an empty or a or a symbol or a number. And then we need to do something with the locations. How are we going to do that? Let's maybe give everything a list of locations in our result. So I'm going to define a location type as well, which is just a type alias for a tuple of ints. So this is a location. Let's declare a line. So we're bundling, let's give this a type. So it's a list of locations and entries, right? Yep, and then the return type will be a list of bundles, and every bundle has a list of locations. Something like this, maybe. So now we just need to line up these types. So we need to return a list, which is what we're building here with this cons operator, and then every element has to be a list of locations and one of those bundles cases, or bundle. So this is now a list of locations and entries, and we know their digits also. So let's now make a bundle of number and group the locations together. So the number is I think we take the second thing, so that's the number, a list of entries, and we know they're all digits, so let's grab the digits. Let's grab the digits from these cases as well. So little helper function that takes entry, digit, D, and that should return D itself. And that will crash very hard if we give it something else than a digit, but we are 100% sure here that they are digits. So this is an int list. You know what, I'm not gonna parse this to int, I'm gonna parse this to string, so it's easier to sum them together or to concatenate them together. So everything stays the same here. This becomes a string, sure. And then making numbers from the digits becomes a bit easier. And yep, so then taking numbers from the digits is what we're doing here. We just concat every string and we parse that into an integer. So that's the number. And it should be a bundle.number. So let's wrap that in the number case. And now we need the locations, which is bundled list map first. And that should be our list of locations. And we can make a location list and bundle tuple now. So that should compile. It does. Now for the other case. For the other case, we need to map to empty or symbol. And they're different types, so we need to do a bit of transforming here. So if it's an entry dot empty, it becomes a And let's extract the position here as well. So if it's an empty, then it becomes the position and bundle.empty. And if it's a symbol, it becomes the same thing, right? But we just map it. And that's the entry we want to put in the end result. Location list does not match location. Oh yeah, we have a list for everything, but empty or symbol just has the single position. We're not bundling those together, only the numbers. So that appears to compile. Let's give it a quick test run. Okay, where are we at? We are at number 467 in 012. That sounds correct. And then we have an empty, and then we have another number. And we have an empty and empty. That looks correct, actually. So let's get rid of the inline test stuff. So I think we have done the hard part. We have done the parsing. And now we can go to the easy part, solving the actual puzzle. So we need to find the sum of all the part numbers. And the part number, remember, was a number that we just parsed that is adjacent. It can be diagonally adjacent to a symbol. So basically we need all numbers, we need locations of all symbols, and then we can work on our problem. So this is our bundled numbers. And let's grab all our numbers out of there and all our symbols, right? How do you do this? So we have locations in D. D should be a digit, and then we have so if D is a digit, then we need it. Then we need it, and otherwise we don't need it. So these are the. Oh, it's a list of a list. Do we still need lists of lists, or can we just flatten? I think we can just flatten. Once we did the parsing, the hard part, we can just smooch everything into a single list, not a 2D list. Yeah, sure. And we have D. D is a bundle, so that's not a digit, but a number, of course. So these are the numbers, yes. Now we have all numbers. Let's also grab all symbols. It's exactly the same, but we only extract or filter on symbols. One, two, three, 4, 5, 6. Is that correct? Yep. Okay. And now we just need to find the part numbers, which are numbers that are touching a symbol. So, part numbers is another filter on the numbers. And we can figure that out given the symbols. So let's write this helper function now. Is part number given some symbols, given a number. I'm a bit bemused by the fact that we are still working with bundles and not with the raw numbers, because I don't care. This can never be a, inside this is part number. This can never be a symbol or an empty. It always is a number. So I would like to incorporate that into what we're doing here. So instead of just filtering numbers, I'm going to choose, which is a filter plus. And if you look at the signature, it's exactly the same as a filter, but instead of returning a true or a false, for your predicate, you return an option of something. And that kind of works in the same way, meaning that if you give it none, it's the same as saying false, but if you give it some, you can provide a value and not just a true. So that's what we're going to use to extract the number. So when we have a number, we want to return the number and all the locations for it. And if it's something else, we return nothing. So now if you look at numbers, it's a list of numbers and all the locations that this number covers. So that's more useful for us. There we go. So it's the number and the locations that we get fed in here, and it should give us true or false. There we go. Everything still lines up. Our compiler is happy. So I think we are good to go to work on this isPart number function. And isPart number, this number is a part number when any of these locations has a neighboring symbol. So actually we don't really care about the symbols. We care about the location of the symbols, right? Yeah, let's make that explicit. Symbol locations is symbols, list map, whatever it is, the first. And it's a list of locations again. I think we can just collect again. We don't need to know, or we don't need to list in a list. We just need a hard list of coordinates, which is this. So we can pipe in symbol locations into this part number helper. So I think now we are really close. Because if of the locations of the number, there is one, so there isn't exists, where has neighbor symbol locations lock, then we have a part number. If one of the locations of my number has a neighboring space in these symbol locations, we are good to go. And this is the same as this, so let's tidy that up a bit. Okay, so we broke the problem down yet again into yet a smaller helper function. Has neighbor in some locations and a lock. Oh. And that returns a boolean. So, okay. How are we going to do this? Now we're getting real close to the to the meat of the matter, right? So diagonal is also a case. So we just, let's calculate all the neighboring spaces from location. So that needs a X and a Y. And let's calculate all the different neighbors. So that's X minus 1, Y minus 1. Y minus 1 means going up one row. So yeah, let's stay in the top row and let's move to the right. And let's move to the right once more. This is my neighbors above. This is left, right. This is below. And let's now fill in all the offsets. I could have, yeah, no, let's keep doing this. So this is on the same row, and I don't need to look at myself, so this middle one can go. And we can do the same for Y plus 1. So these are all the neighbors. Oh, this auto formatter destroyed my beautifully formatted grid. That's not a problem. So Now, what do we want to say? Whether or not there's overlap between locations and neighbors. So let's use sets. And if there's an overlap, we have our answer. So that's a set intersect. Of two sets. And if there's something in there, we have a hit. So intersect those two sets. And if it's not empty, we have neighbors. Yeah, that might be it. That looks like a lot of numbers, but it could be. We had 6. 1, 2, 3, 4, 5, 6, 7, 8. How can we have 6 symbols? Can a symbol have multiple part numbers? 1, 2, 3, 4, 5, 6. Can it have multiple adjacent numbers? Yeah, this one has 2. 4, 6, 7, and 35. It could be. It could be. Let's take a look at the solution. 2 numbers are not part numbers. That's maybe an easier double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, we should end up with 8. Which, this looks like 8, yeah. Every number is adjacent to a symbol, so is a part number, and we have to sum the numbers together. We can use a sum by and grab the first element of every tuple. There we go. It's 4, 3, 6, 1. That is correct. Cool. We might be through part 1 if it also works for bigger data sets. Where did we start using example? Let's write some functions so we can give our own input. This is where we're doing it. So I'm gonna write a parse function. Yeah, I'm gonna write a parse function. We already have a parse function here. Let's rename this one to parse character. And let's wrap everything in a parse input. And let's just have it do this and return parsed. Instead of example, use input. There we go. So now we have a parsing function. We have a bundle function. So now we can do example list map, no, parse. And we should uncomment example again. So we have something for the compiler. Yeah, I think we're good to go. Let's make sure everything still works. Everything appears to work. So let's grab this. Let's put that down here. Let's write a bundle function. We have a bundle function. Let's call this numbers. Let's make a function of this so we can call it. Same here. Where's symbols? Where did that go? Oh yeah, now we can do let symbols equals symbols bundled. And let numbers do the same thing. So we're just shifting stuff around. So we can, oh yeah, the functions have the same name, so that's not really ideal. Cool. What's still not working here? Oh yeah, we just renamed this, of course. There we go. We are getting closer, so now we can wrap this in a function. And instead of example, let's use the input. There we go. That was a very roundabout way to wrap everything in a function, but it works. So let's verify it. 4361, yes, let's run it on our own input. That takes way too long, but it's good enough. Hey, that was part 1. On my second attempt. Spicy. Let's see what part 2 has to offer. Oh, I'm trying to open a solution window here. Solution Explorer, that's what I was looking for, yes. Let's pin that so we don't lose it anymore. And let's start on part 2. Or let's start reading about part 2 at least. Okay, part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. Don't seem to be going very fast though, maybe something is still wrong? Fortunately, the gondola has a phone labeled help, so you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. Storytelling is next level this year. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. So we have gears. So not every star symbol is a gear. We need to be adjacent to 2 part numbers. And the gear ratio is a result of multiplying those 2 numbers together. Find gear ratios of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. This is a gear, this is not a gear, this is a gear. So we multiply these 2 numbers and we multiply these 2 numbers. $670, this is not a gear? Yeah, that makes sense. What is the sum of the gear ratios? That's actually a pretty easy twist, no? I'm actually a bit relieved. The first 2 days were rough. Part 1 of this was rough for me as well. It took a second attempt. But now that I'm reading part 2, I think we're close by. So what changes? Instead of starting from numbers, maybe we start from the gears? Or we could only take a look at gears. That's actually saying the same thing, no? Yeah, let's grab, instead of let's grabbing symbols, let's grab gears. So symbols. Yeah, I'm gonna rename symbols to gears. Or let's write a new function called gears, which gives the gear locations. That's maybe even better. So bundled filter if it's a star symbol, which is a gear. We could also change our parsing, but this is good enough, right? Yeah, that's a gear location. So we return We can also do the choose hack here. So if we have something, return some location, and in all our cases return nothing. So now we expose all the gear locations. And instead of using symbols here, let's grab gears. So we have our gear locations, we have our numbers, and now we just need to filter out all gears with exactly two neighbors. Exactly two part numbers, yeah. And not every number was a part number, right? Maybe we should have kept the symbols. Yeah. So let's keep the symbols so we can find the part numbers. Then we have the gear locations. Then we can find our possible gear locations. Then we can find the real gears, and then we can continue. It might be a bit of overkill, but I think no. I think we need all this information. So I'm gonna copy paste. I'm gonna steal my gear locations, or my symbol locations, sorry. There we go. Part numbers is still relevant. Numbers is still relevant. Gears, that's the new part, right? So we're just gonna build on what we had. We're not gonna replace anything. Gear locations is not all of these locations are gears. And now we need to filter those. Or let's put the part numbers next to their gears, and let's filter out all the gears where we have two part numbers next to them. So let's do a map with their part numbers. So let's do a map over possible gear locations where we append the adjacent part numbers to every gear, and then we can filter out when we have exactly two. So helper function yet again, neighboring part numbers given the part numbers for this gear location. So let's write this helper function. Let neighboring part numbers given part numbers and a location. And let's return the gear location as well in the result. So we have gear locations. And let's make this one list and not a nested list. So do I select many or collect with ID? Then we flatten it. So gear locations now returns a list and not a list of a list. That's better. So neighboring part numbers, given part numbers and a location. We already calculated offsets. Let's just do it the same. I'm just gonna copy paste it because that's fast. The fastest. Do we need this? Yeah. So this is X, Y. These are all the neighboring locations for X, Y. And now we need to return all part numbers where one of these coordinates hits. And it cannot overlap with the gear itself? No. So yeah, that's what we have to do. And yet another function. Part number is the number and a list of locations. Yeah, let's just pipe that in. So this is the part number, which is the number and the number locations. And that returns a true false. So we can do the set magic again, yeah? If one of these overlaps the other, we have a collision. So, same thing. Same thing. Actually has neighbor in. Can we not literally use that? You say a list of locations that the neighbor is somewhere in there. Yeah, that's exactly what we're doing, huh? So where are we doing this? Location is 1, so yeah, we can use has neighbor. And neighbor has locations, not part numbers. We're gonna need those part numbers though. Yeah, okay. It would work, but we're almost there, so I'm just gonna do the same thing here. We have here in overlaps we have 2 sets of locations. We can do the same thing. Let's do the same thing. The set magic. So we have locks. We have number locks. And we don't care about the actual number in this overlap function. No squigglies, so we might have a working with number. Whoa, this is a list of a list of a list. I don't even... Where are we building lists of lists? This is already returning crazy stuff. This is returning a bool. Where is our explosion of... This is a list of a list. Part numbers. Oh yeah, but this is correct. Yeah, it's just a list, sorry. Yeah, I need to wake up a bit. What is this actually representing? A location of an int, of an int, of an int, of a list, of a list, of a list. This is really hard. What did I fabricate here? So it's the gear location. That's the first element. That's location there. And then we have a number with the location of that number. So yeah, it's a bit cryptic, but it's actually correct. We don't need to flatten anything here. But now we can filter our actual numbers or our actual gears when we have 2 numbers in there. So let's filter. Yep. So let's filter, and now now we have the time to think. This X here. So that's the location of the gear location and other stuff. And this other stuff is a number and the locations the number provides, but we don't actually care about the location of the numbers anymore at this stage. So we can just say for the filter we can just say only grab ones where other, so where we only have 2 numbers adjacent. So now we have the actual gear numbers, and now we can do the gear ratios, which is multiplying the 2 part numbers we end up with, and then adding up all those individual gear numbers. So let's calculate the ratios. So it's actual gears. Let's do a second to grab all the numbers for every gear. And then we need to multiply the elements in there. So that's grabbing the first element of everything. And then multiply those two things together. And that should happen for every gear. And then we can just sum those gear ratios. That should actually be the sum of the ratios. So that's summing all the ratios. And that is actually the result we are looking for. Phew! That should actually probably maybe be a good first attempt, right? Let's give it a try. 4, 6, 7, 8, 3, 5. That looks correct. So let's see whether or not we can handle our big input. I'm also going to put on a timer because part 1 took a long time. Relatively long time. It took us 3 seconds, which is not little, but we have an answer. Which is the correct answer. So we're done actually. Surprising. I surprised myself in a good way, but also in a bad way. Let's maybe quickly recap what we did. So for day 3, we did the hardest work while parsing. We did like some indexing using this indexed trick. We used some list comprehensions. We parsed out some intermediary structure where we already know what's a digit, what's an empty space, what's a symbol. In phase 1, the next step, we bundled our digits that were next to each other into full-on numbers. Yes, that's what we did. And then we just started looking around, looking at neighboring spaces. And for part 2, we had to do a little bit more work, finding gears, finding gear ratios, but not too complicated. What don't I like? I don't like that I took huge steps just typing without seeing stuff work. That's something I would rather do, but we didn't end up doing that today. And what I also don't like is, if you look at these types, location, int, list, future me will not be able to comprehend this. So maybe I should have taken smaller steps. Maybe I should have introduced some more types, or maybe I should have introduced less types. But I don't think this, I will look favorably upon this code a month from now. I mean, interpreting what's happening here is already tricky for me, and we just wrote this 10 minutes ago. So might clean this up later. I might not because it's Sunday and I also have other things to attend to. But fun puzzle. Took me 2 attempts, but I'm happy we got there in the end. This was day 3 in Advent of Code, in F#, of course. And I hope to see you tomorrow for day 4. Bye-bye.